Okay, for this problem, we're given 16x squared plus y squared minus 192x plus 10y plus 585 equals 0. Find all vertical and horizontal tangent lines. Okay, so in order to find tangent lines, we're going to first need the derivative. And this, given that this is not solved for y for us, we're going to need to take the derivative implicitly. Okay, so we'll do this term by term. We'll start with a 16x squared. The derivative of that would be 32. Let's write down that we're taking the derivative. Here. Okay, so the derivative of 16x squared would be 32x. The derivative of y squared would be 2y, and we'll put a little dy dx since we're doing this implicitly. And then negative 192x would become negative 192. 10y would become 10 dy dx. And 585, the derivative of that is 0, so we won't write it. And then the derivative of 0 is still 0. Okay, so there's your derivative. Let's clean that up. Let's solve for dy dx. Okay, so I'm going to move these two terms over, the 32x and the 192, to the other side. And I'm going to factor out the dy dx out of both of these terms. So let's go ahead and put the dy dx out front. That leaves the 2y plus 10. Okay, so that was the two terms that were connected to the dy dx here. Okay, so 2y plus 10, there's the dy dx out front, equals, and these two terms, remember, they moved over, so it's going to be 192 minus 32x. Okay, now when we divide this over so we can get the dy dx by itself, we'll be given dy dx equals 192 minus 32x over 2y plus 10. Okay, so that's our derivative. Now, the problem asks us to find vertical and horizontal tangent lines. Okay, so a tangent line is horizontal when the derivative is equal to 0. Okay, and a tangent line is vertical when the derivative is undefined. Okay, so the first thing I want to do is find the horizontal tangent line, or lines. Okay, so when we have a fraction, when you set that thing equal to 0, the denominator doesn't really do anything because you can just multiply it over and it turns into 0 anyway. So you set that equal to 0, the 2y plus 10 immediately goes away. So I'm just going to pay attention to the numerator, and I'm going to set that equal to 0. Okay, again, I'm setting the whole derivative equal to 0, but the numerator or the denominator really doesn't matter. Okay, so when I move that 192 over and change the signs on both, I get 32x equals 192. Okay, and that becomes x equals 6 when I divide the 32 over. Okay, so we have x equals 6. Now, what do we do with it? Okay, well, we are looking for horizontal tangent lines. X equals 6 is not a horizontal line, right? That's going to be a vertical line. So we need to find the corresponding y values that go with x equals 6, and that means we have to go back to the original equation, okay, and plug this 6 in right here in place of x, and then solve for y. Okay, so go back to the original here. Let's do it right here. So we have 16 times 6 squared plus y squared minus 192 times 6 plus 10y plus 585 equals 0. Okay, now when we clean all this up, this is going to be a big number. It's like 500 and something. That one as well is going to be a big number. When we clean that all up, we get 9 for all the constants. So y squared plus 10y plus 9 equals 0. So you can do that in your calculator if you want this term, and this term all combined up. You can't see that. Those three terms all combined will give you 9. Okay, so we need to factor here. So the two things that multiply to get 9 but add to get 10, that's 9 and 1. So y plus 9 and y plus 1 equals 0, which gives us solutions of y equals negative 9 and y equals negative 1. Now those are horizontal tangent lines, y equals negative 9 and y equals negative 1. So those are solutions for the first part of the problem, the horizontal tangent lines. Okay, now for the vertical tangent lines, okay, let me go back up here to this equation. Let's do this again for the vertical tangent lines. Okay, vertical tangent lines. Okay, we need to, that's where you are undefined. Okay, that's where your derivative is undefined. Derivative equals undefined. And how is a derivative undefined? Well, there's multiple ways, but in this particular case, since it's a fraction, fractions are undefined when they're 0 in the denominator. So we can set 2y plus 10 equal to 0, which will give us 2y equals negative 10, y is equal to negative 5. And that is the y value at which the derivative is undefined. Okay, but as we know, y equals negative 5 is not a vertical line. It's a horizontal line. So just like we did last time, we would do the opposite this time. We're going to plug in the negative 5 in place of y into this equation right here. Okay, so in place of y. So I can even move this up real quick so you can see what I'm doing here. Okay, so we have 16x squared plus negative 5 squared minus 192x plus 10 times negative 5 plus 585 equals 0. Okay, so the 16x squared minus the 192x, okay, then you've got 3 constants. If you add all those up, you'll get 560 equals 0. Now, we need to factor this, but those are some big numbers to be factoring. So the first thing, when you have big numbers and you're looking to factor something like this, is try to divide something out. And the obvious choice is always going to be whatever the number is in front of x squared, because that would make things as easy as possible. So in this case, it does actually work. We divide by 16, and we get, let's see, x squared minus 12x plus 35 equals 0. Okay, now we can factor that out. That becomes two things that multiply to 35, add to get negative 12. That's x minus 5, x minus 7. Set those both equals 0. You get x equals 5, x equals 7. Now those are vertical lines, so these are our vertical tangent lines. Okay, so we've got, these are our vertical tangents, and these are our horizontal tangents. And that's it.